couple other things here. Just doing an auto save in the background. I'm going to hide the plastic one, and I want to show this casting here. So this could be a STL file or a normal, step-like file, so, NURBS or faceted. And a lot of times on something like this, we want to cast it, but there's casting shrinkage, and we want to offset the walls a certain amount. So oftentimes this could fail with the normal shelling operation, but sometimes if we're going to 3D print some patterns for the casting, it's already in the STL state. So what we could do with either of the kinds of models is use the shell tool, but actually shell outward. And we're not going to do an infill here, so I'm going to turn that off, and I'm going to show outside. So let's say we want to add a certain amount to this. We want to add 10,000. So I enter in that value. I'm going to keep the original one so I can really show you what's happened here. But I'm going to go ahead and click the check mark. Here it's shelling, instead of shelling inward. So shelling is just an offset of the faces in one direction, normally inward to hollow it out. But you can also shell it outward. So that's what we've done here. And I'm going to escape out, and I'm going to select Y and Z and go into a cross section. And actually, I'm going to select one of these, and I'm going to change the color. So what we actually have here is the original inner body, and added onto it is like a layer, a film, a skin, but with a thickness. So what it did was it took the outside face of the inside body, in essence, copied and pasted it. It reused it. And then it offset it outward, and it made a body out of that. So, there's a lot of applications for this. If you literally need to make a skin or a film for something, this will do it right here. But if we want to have, whoops, hit the wrong one. If we want to have just the outer wall and not the inner wall, you'll notice this is hollow outward. That's easily doable. So if we go back to our facets add-on here, there's the separate tool. So if you think about it, this inner wall doesn't touch the outer wall. There's always material between it. So they're really just one body subtracted from another, and you can separate them. So if I turn on separate and I just click on this wall here, you'll notice I now have two. And I'm going to escape out. I'm just going to right click to use the last sketch plane here. And you'll notice that it doesn't really look hollow anymore. We have one body like this with either the inner or the outer wall, and then we have another body like this with, in this case, I guess this is just the inner wall. We're going to be able to do an auto fix just to make sure the triangle is in the right direction, but this one is highlighting the inside area. This is highlighting the outside area. That's what I'm looking for. So let's just go ahead and delete this one. So now I have, overlapping bodies. I've removed the inner walls, and in essence, this is just like pulling all of the faces or offsetting all of the faces to add material. So if there's any shrinkage, and what's really important to note here is that a lot of people will tell you you can just scale a model, when we are able to do that here. But the one thing with scaling is that if I scale it, it always scales about a point. So if I scale it, the distance between this axis and this axis changes. When you offset, there's no reference that it's scaling away from. Everything goes in a normal direction. So, here they would collapse in on this axis. These would collapse in. So for a lot of, very important dimensions, shelling, offsetting is needed over scaling. There's one other thing that, or a couple things I want to show here. We mentioned or mostly showed using the shell tool on a normal solid. But what if we only have an STL and we want to remove faces? Well, it works the same way. Let's go back to inside here, and let's say 50,000. And it works the same way. You select the body that you want to shell, and then with the next tool guide, you select the faces that you want to remove. One really useful way with STLs is double clicking, because when you double click, it grabs all of the triangles that are near tangent to that, and we may have to do a control double click to grab that one, though maybe it wasn't quite so tangent at the top there. So now that we have these selected, let's keep the original body, let's leave the infill off, click the check mark. I'm going to escape out. And remember, I said keep the original body. So if I hide this first one here, here we can see it's been shelled out to the inside. The more we select, if I undo to here, I could also, with this tool guide, include this group here. Let's see what that looks like. Hide that one. And here there's some extra pieces. Very easy to just grab those and delete them. Now you'll notice it didn't grab all of those faces. So I'm just going to undo. One tip with box selecting on an STL is to set this filter here, this selection filter, to through. Then when you box select, it grabs all the faces that are there and you can delete it. And now, you could fill this with sand and 3D print the head and just screw that on if it needs some extra weight. That's a really good application, is that 3D printing material is expensive and oftentimes light. You could just grab some sand or some rocks, pour it in, put the head on, and now you've added extra weight and also saved on cost. Now, one last option allows you to do a custom infill. So basically, what's needed for the custom infill is a flat 2D surface. It could really be whatever you want. Just whatever. You could create it with our sketch tools. You can bring in or create a note, and then use the either project to sketch or the project tool, project it onto a surface, depending on what mode you're in here. But basically, you set it up the same way. With the shell tool on, you pick the body to shell. You can choose faces to remove or not. If you're going to do something like this, it usually is something like maybe a customer logo, something you want to show off. Not that one there. And then you use this tool guide and you pick that surface. You click the check mark. I already have some created here. So there are a few different options within here. There's whether it's a square pattern or a grid, the sizing, and what type of fill it is. So I'll show you a few different ones here. So this is the standard. You'll notice that if I rotate, and actually we could just click on Z here, what it's done is it's cut a pattern with the surface. So it removed the material where the surface is. There's another option that allows you to do the opposite of that, and instead of cutting material to remove, it allows you to add material. So that's the last one here. Notice here that the material is added where the surface was as opposed to the opposite. The other option, the one at the top, is whether it's going to kind of square off the boundary. So the surface that I made wasn't quite so square. And so you'll notice there's a little space at the bottom. If I had made it more square, it would have done it, and filled in that space. That is with the square grid. There is an option here for rectangle grid. You'll notice that it compresses the pattern a little bit closer. There's also an option to scale to fit. Scale to fit would expand it over, kind of like the background settings, your background images on your computer desktop. Here it's patterning it. The other option would be to stretch and fill it. And those are all the different options. You saw the last one where instead of cutting material, it adds. A tip on here, you probably want to scale to fit, because you'll notice there isn't any material going all the way down here, because there is just it's adding like a space. So here a scale to fit would have stretched it over and made it a little stronger, because the surface is connected all the way across. So hope you have learned something about the shell tool, and happy modeling.